Okay, so we were talking about how we have this pituitary gland, and it's got this one part, the anterior pituitary, which is glandular, and it makes hormones. Not a surprise. We have this other part, and it's nervous tissue. Yeah, the posterior pituitary is nervous tissue. And it's going to release hormones that are made in the brain that were transported down to the posterior pituitary. I told you, it's a little bit funky, a little bit squirrely here in the endocrine glands, endocrine system. So anyway, so we have a hormone called oxytocin. And what it does, and you may know it if you depending on if you've had a baby or have raised animals, maybe, you might know it that way too. But it is a hormone that induces labor. So oxytocin is the hormone that when you get uterine stretch and the uterus starts contracting late in pregnancy, what happens, this contracting causes your brain to secrete, this posterior pituitary gland to secrete oxytocin. And what does that do? It causes more contractions. And the more contractions cause the release of more oxytocin, which causes even more contractions. And as they say, baby pops out. Not quite that easy, is it? No. But it causes you to give birth. Now, so that's one of the functions of oxytocin. Remember on one of the previous videos, I mentioned prolactin. And I said prolactin is responsible for the synthesis of milk. Well, it ends up oxytocin has another role. That's in the milk ejection. I had a student who, I guess, it's not always convenient to carry your baby around with you, right? And so what she would do is she would milk herself so that she had her own milk to feed her baby. And she had some kind of an electronic pump. And one time she told me this story that one time her mom was visiting her house, visiting her grandbaby. And mom was trying to help, and she was cleaning this pump thing, and she kept turning it on and off to run water through it. And my student said, oh, I had to stop her because it was causing oxytocin to be released and causing milk ejection. So oxytocin causes milk ejection. Another related thing is if you know anything about dairy farming, everyone knows about dairy farming, right? No, not necessarily. But if you do, the first thing that a farmer does before they milk their cow is they clean off the teats and then they strip a little bit of milk out. And that's the same as suckling. And suckling on the breast or stripping a little milk out causes the release of oxytocin, which causes milk ejection. So the two hormones involved in milk are prolactin, milk synthesis, oxytocin, milk ejection. Okay, good. All right, so we have oxytocin, which is posterior pituitary, and then we have antidiuretic hormone. And people probably, you say I've heard of diuretics, but antidiuretic? Well, it's kind of like I was saying in the previous chapter. I'd said your body is not worried about you having high blood pressure or anything like that. It worries about you dying of thirst. And so you have this hormone, antidiuretic hormone, which is similar to one that I'd mentioned, your body trying to maintain body weight, But anyway, this antidiuretic hormone, it's there to prevent you from dehydrating too much. And so it causes you to reduce the amount of water that you're losing in your urine when your blood becomes too dehydrated. So your kidneys are monitoring for this condition. An antidiuretic hormone is a hormone that is released, which causes you to retain more water. And as a result of that, I noticed on my slide here, it says it has a minor role in increasing blood pressure. You retain water, you increase blood pressure. Okay, moving right along, we come to the thyroid and parathyroid. Now, why do I say them together? I say them together because they are together. They're two different hormones in the exact same location. The little bitty parathyroid nodules are embedded in the thyroid. So when we look at these hormones, I have a picture of a thyroid gland, and you can see the thyroid gland and then the parathyroid gland nodules in there. Now next to it, I have a diagram, and it's showing, a kind of a schematic of a thyroid, and then it shows a microscopic view of the thyroid. And I want you to pay attention. You see it says follicular cells and extrafollicular. So follicular meaning follicle. Now I mentioned follicle a minute ago. I said with the ovary, we were talking about ovarian follicles. Here with the thyroid, it's thyroid follicles, right? So it's not the same thing, but they are fluid-filled cavities. And so the fluid-filled cavity is lined by follicular cells, and then the ones that aren't directly connected to the follicle, they're the extrafollicular cells. Now, why did I go through all of that? Well, we're going to talk about hormones that are secreted by the follicular cells and other hormone secreted by extrafollicular cells. You see, we mention things for a reason. So when we look at these, if we start looking at thyroid hormone from the follicular cells, and it's put in the follicle, and it builds up in the follicle and is released from the follicle, we have thyroid hormone, and thyroid hormone is going to be a metabolic hormone. It's kind of like blowing on a match or blowing on the fire to make it bigger. You burn more energy, right? So as thyroid hormone levels go up, your metabolism increases. So in the follicle, what they call the colloid, that fluid in there, is filled with thyroid hormone. Well, it ends up, we have two different forms of thyroid hormone, T3 and T4, triiodo-309, and let me see if the triiodo-309 and thyroxine. So the T4, and it's two different forms. So the T3, the triiodo-309, is the active form, and we've said, what does it do? It affects metabolism, so it affects most cells. And then the other one is the inactive form. Now, what is it referring to? T3 and T4. It's talking about something. It's talking about something called iodo. Not iodo, iodine. It's referring to iodine. So it ends up that these hormones have iodine in them. And you may, I don't know if in your time, you probably have never seen somebody with a goiter. But when I was growing up, we didn't have iodine in salt. And so if you don't have enough salt, your thyroid gland gets really huge, and it's called a goiter. And I remember as a little kid, it kind of horrified me when I saw it, to be quite honest. But it's because of that. So once they started adding iodine to salt, we don't tend to have that problem. So anyway, the hormone that is produced by the follicular cells and the thyroid follicles is thyroxine or triiodo-309, and it's metabolic hormones, and it increases metabolism. All right, so if we have then we had said we have, the extrafollicular, the other one. And you know it, you already know it, it's so good. It's calcitonin. Remember that one from the skeletal system? I know you know that. What did we say it does? It causes you to take excess calcium from the blood and to use it to build bone. And then we had said we have this other hormone that is from the parathyroid gland. It's right in the same location, different gland though. And what did we say it does? Oh yeah, it strips calcium out of the bone and puts it calcium ions into circulation when the levels fall. So calcitonin and parathyroid hormone are one of those that are controlled by serum blood levels of calcium ions. All right, I'm going to stop right here and we're going to come back and talk about the adrenal gland.